Good morning, ladies. It is Wednesday. Yes, Wednesday, April 22nd. And in Alva, it is currently pouring down rain, and it has rained all night, and it is glorious. Enjoying it thoroughly. But I'm coming to you from my home this morning because, not going to lie, I just didn't want to get out and go to school. So I was able to do everything here. So, just want to, again, we're working through chapter 13 with just a lot of activities. Remember, your Tangram story is due on Friday. I've read a couple of those already, and those have been super fun. So I'm excited to read the rest of those. And if you are making a Tangram story and you just do not want me to share it on Monday, then let me know. Okay, you don't have to share yours, but if you just do not want me to share it, please email me and say, hey, just don't share that. Okay, but I'm telling you, the ones I've read have been good. So you guys are super creative with that. So, and I am just, as those are coming in, I'm just getting those graded and in the grade books. So. Okay, so today what we want to talk about are what's called dilations. So we talked about the mirror on Monday, and hopefully that's something that you would like to try when you get back to campus. Feel free to come over and play with one of those at some time. But today we want to talk about what a dilation is. And a dilation, again, we're working within isometry, and isometries preserve distance. So an image under isometry is congruent to the original image, okay, to the original image. Now, a different type of transformation is created when a slide is projected onto a screen, and this is called a dilation. The objects on the screen are enlarged from the original size on the screen by the same factor, and we call this a scale factor. So everything is enlarged by a scale factor. So if we think about it, we have this original image, and then it's projected just like it's projected onto the smartboard, projected using a projector, a movie. Okay, as you go to a movie, that is totally dilation at work. You're taking from this and you're broadcasting it in by some scale factor up onto a projector. Okay, up onto a screen. And so a movie theater is a perfect example of dilation. And the scale factor can change, okay? And the scale factor is what keeps things from being pixelated, okay? So, when you take a picture sometimes, and if you don't take it by the corner, if you take it by the side or the top, it becomes either really wide or really skinny. It becomes, and if you get it too big, it becomes pixelated. So what a scale factor does is it takes each piece, okay, and it gets it to where it looks exactly the same. So. Okay, so if we look at this example, okay, we have the triangle that's in the black, okay. Each side of triangle A prime, B prime, and C prime is twice as long as the corresponding side of triangle A, B, and C. And so this would be an example of a two-dimensional dilation, okay. So we're taking the black triangle and we are multiplying the length of that side by 2. So if you notice, side AC is 3 blocks long, okay, and it's twice, and then the dilation is twice, so 3 times 2 is 6, so A prime, C prime is 6 blocks long, okay. So again, each piece is double, okay, or twice what the original is, okay, what the original is. Now, I have a couple of dilation activities. One is just working with shapes, okay, and graphing. And the other one is King Tut's tomb, okay, where you're graphing the original King Tut's tomb and then you're multiplying by a scale factor, whether you double it or whether you make it smaller by multiplying by a fraction. So there's 2 activities there. You can do those with graph paper, without graph paper. The one does include graphs, so you can do it with that. If you're doing King Tut's tomb, then you will need some graph paper, and I will upload just a sheet of graph paper for you if you don't have any laying around. So, which most people don't. It's a math teacher problems hashtag. So I will upload that. I also want to show you Nope, that's for Friday. Never mind. So I'm getting stuff around for Friday's lesson of tessellations, which is really fun. So for Friday, you need to be, you're going to need a blank piece of paper. Okay. You're going to need a another piece of paper, and if it's a thicker paper, that's great. If it's not, if it's cardstock, it doesn't even have to be paper. It can be the side of a box, or it can be something like that. So it can be thick. Sorry, my neighbor's coming in. His truck's loud. So you're going to need a couple of things for Friday, okay, and then scissors and tape, and then I will show you to get you excited about tessellations. So I'm looking forward to that. So I will make another video kind of going over those dilation activities for you. So if you have questions, please reach out, and we will go from there. So have a great day, and if it's raining where you are, enjoy.